So this lesson is about making inferences from random samples of data. So we're going to look at making inferences from a dot plot, making inferences from a box plot, and then we're going to look at making inferences just from a sample using proportions. So first, a dot plot. So it says Rosie asked students on the lunch line how many books they had in their backpacks. She recorded the data as a list. So the list is how many books each student had in their backpack. Make a dot plot for the books carried by this sample of students. So our data goes from 0 to 6. So we're going to start off by making a number line. It goes from 0 to 6. So 0, 1, 2. Don't skip any numbers. This needs to be sequential. 5 and 6. And then I'm just going to put a dot for every time that number occurs. So in my data set here, there's 1, 0. So I put 1 dot. And I see how many ones there are, and there's 2 of those, so I put 2 dots. There are 3 2s, so 3 students had 2 books. No one had 3 books. 2 students had 4 books. No one with 5, and then 1 big-time reader with 6 books in their backpack. So now, this is just a visual representation of our data. So it makes it easier for us to make inferences or conclusions about it. So the first thing they ask is, how are the number of dots you plotted related to the number of data values? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 dots, and there are 9 numbers in our data set. So they're equal to each other. So the number of dots will tell you how many elements you have in your data set. Now it says complete each qualitative inference about the population. So the first one says most students have blank 1 book in their backpacks. So if you look, most of the students have, there's only 1 student that doesn't have at least 1 book. So every student except 1 had 1 or more books. So I would say most students have at least 1 book in their backpacks. So this is an inference about students at the school based upon this sample. So we would say about the school that most students have at least 1 book in their backpacks. All right, let's see what other ones we have. So this is the one we just did. Most students have fewer than blank books in their backpacks. So most students have fewer than what? So if we look, you could say most students have fewer than 6, right? Because most of them do. All of them do except 1 in our sample. But that doesn't really, it doesn't clear things up that much. I can't think of the right word to say here. But you want a statement that makes an impact, that's true. You could say most students have fewer than 4. That's also true. But it would be a better statement if you said most students had fewer than 3, because most of our data is right here. Out of the 9 students, 6 of them have between 0 and 2 books here. So the best statement would be to say that most students have fewer than 3 books in their backpack. That's just the best statement. 6 books, if you put 6 here, that wouldn't be wrong, but it's not as good of a statement as saying most students have fewer than 3. And then I kind of just answered this one. Most students have between blank books in their backpacks. So if we go back here, most of our data, again, is right here. So we would say most students have between 0 and 2 books in their backpack. So most students have between 0 and 2 books in their backpacks. What could Rosie do to improve the quality of her data? Well, whenever you do samples, the answer to this question is almost always the same, which is ask more people. So the more people you have in your sample, the better your sample is going to be, the better the quality of your data. The whole point of sampling is to get an idea about the whole population. When you can't ask everyone in the whole population, you do a sample. So the more people you have in your sample, the better the quality of your data. All right, so now let's do the same thing with box plots. So in a box plot, the first thing to do is to put your numbers in order from least to greatest. Sorry, that's skipping around on me. So we're going to put the numbers in order from least to greatest down here in these boxes. So the first number is 0, and then I have 2 2s. I'm crossing these off to make sure that I get all the numbers. And then I have 2 3s. And then I have 4, and then 5, and then 6, and then 9. So you put your numbers in order from least to greatest, and to make a box plot, you need 5 values. The first value you need is the smallest value in your data set, which is 0. The next data, well, let's start here in the middle. So then the next one you need is the median of your data set, and that's just the middle number. So you cross these off till you find the middle, and the middle number here is 3. The greatest value, we need that. That's 9. So we have our least, our greatest, and we have the median. Now we need to find what's called the lower and the upper quartile. Quartile, because we're dividing this data into quarters, into fourths. So the lower quartile is just the median of this lower half of data. And so the number in the middle is between 2 and 2. And the number between 2 and 2 is 2. If you have two numbers and you're not sure what it is, then you just add those and divide by 2. So 4 divided by 2 is 2. Over here, it's between 5 and 6, and so that's going to be 5.5. And again, if you didn't know that, just do 5 plus 6 is 11, divided by 2 is 5.5. So those are the 5 values that we need for our box plot. And so to do the box plot, you first start with a number line. So 0, 1, 2, 3, 4. Make sure you don't skip any numbers. Make sure everything's sequential. 9 and 10. And then I'm going to plot these 5 values. So the first value is the least, that's 0. The lower quartile is 2. The median is 3. The upper quartile is 5.5, so between 5 and 6. And the greatest value is 9. And so box plots, we used to call these box and whisker plots because it's got these whiskers on the ends of it. So these are the whiskers. And then in the middle, you have a box, hence the name box plot. And then you just put a line through the median. All right, so we've got our least value here, 0, greatest value, 9. Our median is 3, lower quartile is 2, and the upper quartile is 5.5. And so again, what a box plot does is it splits your data up into fourths, or 25%, so 25%. So the median splits your data in half. So half of my data was less than 3. Half of my data was greater than 3. See, look at the numbers here. Half my data is over here, half the data is over there. So then we take this lower half and we split it. So now what I've done is I've created fourths or quarters, hence the quartile. So each of these sections contains 1/4 of my data, or 25%. So each of these is also 25%. And I have a video on box plots, if you want to watch that, that goes into more detail about box plots. So now they're going to ask us some questions based off the box plot. So the first question says, a good measure for the most likely number of pets is. What they're asking us here is whether you should use the mean or the median to find the most likely number of pets that someone would have. And whenever you have a data set that has outliers, this 9, I would say, is an outlier. So most people had 2, 3. 2 and 3 is what most people had. 9 is like way out here. So that's like some crazy animal person with 9 pets. I shouldn't talk because I have 4 dogs and 3 cats and some fish and some chickens. So I guess I'm over 9 if you want to call fish and chickens pets. All right, so since there's an outlier, the median is a better value to use. So when you have an outlier, then you want to use the median. If you don't have outliers, then the mean is the best thing to use. 50% of the students have between blank and 3 pets. So remember that the box plot divides your data into quarters. Each of these sections represents 25% of your data. So 50% of my data falls between 0 and 3. So 50% is here. The other 50% is between 3 and 9. So each section represents 25. So 25 plus 25 tells me 50% of my data is between 0 and 3. So that's what we're going to put for that. This one's a little, I don't know. Well, let's see. Almost every student in Parkview has at least blank pet. I should say pets. Almost every student in Parkview has at least what? Well, probably the best way to go about doing this is that 75% of the students have less than 5 pets, or 5.5 actually. So since 75% of my data is here between 0 and 5.5, the best statement I could make is to say that most students have at least 5 pets. If I just looked at the data set, I might change that answer. I might say most students have at least 3 pets, because that's like half of your data. But 75% is better for the word most, so I would say at least 5 pets. All right, so now we're going to use proportions to make inferences. So in this example, it says a shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 and finds that 3 of those are defective. So he didn't have time to check every single one, so he just checked 50 of them. And out of the 50, 3 were defective. So using that information, they want to figure out, well, how many should we expect out of the 3,500 to be defective? So we do that whenever we're making a prediction off of data, we're usually using a proportion. So here's our proportion. The proportion is 3 out of 50 were defective. We want to know how many out of 3,500 will be defective. And so if you set up this proportion and then solve it, you'll get an answer of 210. So now it's going to ask us, the next question on the next page is, well, what if he found 6 defective out of the 50? Well, since 6 is twice as many as 3, you can just double this answer, or we can write a totally new proportion and solve that. But if he found twice as many defective, then this would be twice as many also. But I'll write the proportion out for you. So how many MP3 players would you predict if 6 of them were damaged in the sample? So the proportion would be 6 out of 50 equals X out of 3,500. And again, if you multiply 6 times 3,500 divided by 50, you'll get 420. All right, so I'm not going to answer this last one. I hope that this was helpful to you. If so, give it a like and a subscribe. And until next time.